All right, let's do this. Limit is an evaluation. And if you can't evaluate it, is it indeterminate, or we can do L'Hopital's rule or factor or whatever. So step number one, if I evaluate here, 2 plus 5 is 7. 2 take away 2 is 0. This is not indeterminate. This limit doesn't exist. That is an asymptote. If it was 0 over 0, then we can factor L'Hopital's rule. My camera. All right, let's plug in. Use your mental brains. 1 plus 1 take away 2. That's 0. That's 0. Beautiful. You have two options. I'm going to use this option. So instead of factoring, I'm going to take the derivative and then plug in 1 and then get my answer. You could get the same answer by factoring, crossing out, and so on. Why not use L'Hopital's rule? That's the derivative of the top and the derivative of the bottom. Value of cosine of pi. There you go. It's -1. The value of the limit as x approaches 4. That's 6 over 8. Limit as x approaches 0. That answer is 0. I know it's blurry. We got this. 1 plus 2 take away 3. That's 0 over 0. That's indeterminate. I'm going to use L'Hopital's rule. Make sure you use limit notation. That's 2x plus 2 over 1. Plug in and you get your answer. You should try this first, right? Plug in 1. Now this one's different. So this is not going to be L'Hopital's rule. Could use L'Hopital's rule. It is indeterminate. It is 0 over 0. So what would L'Hopital's rule go if I did it that way? So if I did L'Hopital's rule, it would be 1/2 to the -1/2. And then if you plugged in 1, I think it works. The answer is 2. So that's just doing L'Hopital's rule. The other way would be if I want root x plus 1, top and bottom. How would that work? I just want to make sure it's the same answer. It's the same answer. Beautiful. All right, same thing here. I would use L'Hopital's rule. So first of all, is it indeterminate? Yes. The derivative of the top, the derivative of the bottom. So in my brain, I put it calculus friendly, then 1/2 and then -1/2, and then the derivative of -2 is 0. Then plug in 4. You might have to use a little bit of thinking here. So what does this mean? 4 to the -1/2. Well, 4 to the +1/2 would mean the square root of 4, which is 2. But the negative makes it not 2, but 1/2. So I end up with 1 over 1/4, and 1 divided by 1/4 is 4. So you still have to think a little bit. All right, how about this one? So this is right-hand behavior. Notice the numerator is slower than the denominator. The denominator is more powerful. You could also use L'Hopital's rule to prove it to yourself. Here, if I plug in 0, the value of sine at 0 is 0. E to the 0 is 1, take away 1. It's indeterminate. This is L'Hopital's rule. So the value, the derivative of sine is cosine. The derivative of e to the x minus 1 is e to the x. Now plug in 0. Cosine at 0 is 1. E to the 0 is 1. So the answer is 1. End behavior question. Power term over power term. So if I go 2x times 9, do you see the 9? 3 squared, 9x squared. So 2 times 9, this would be the same as the limit as x approaches it of 18x to the 3, 9 times 2. 2 cubed, that's 8x cubed. So the answer would be 18 over 8 or 9 over 4. Both are good answers. -1. A -1, take away 1 is 0. -1 plus 1, that's e to the 0, that's 1. And then 2 take away 1, so this answer is just 0, right? Try it again. So -1 take away 1 is 0. -1 plus 1, that's e to the 0, which is 1. So it's 2 take away 1, which is 1. So it's 0 divided by 1, which is 0. Okay, so make sure you know it's indeterminate. Next page, some derivatives. Do you know your rules? This is called the product rule. Try it first. The first times the derivative of the second plus the second times the derivative of the first. This one we need to write calculus friendly. You should try all of these first, right? It'd be a shame to watch the video first and then do it, right? You do the work first, then watch it. You don't have to simplify these. When I subtract one, -1 take away, that's -3/2. And then the hook, which would be 2x plus 3. The derivative here. So first of all, calculus friendly would be cosine x squared minus x to the 3. That's calculus friendly. So 3 first. Copy everything. Subtract 1 to the exponent. The derivative of sine is negative sine. Copy everything that's left. And then I'll do it down here. And then the derivative of x squared minus x. So make sure you follow the hooks all the way through. Next one, try it first, please. This is the quotient rule. That's the bottom times the derivative of the top. Subtract the top. Oops. So the bottom times the derivative of the top, and it has a hook of 2. Sorry. Subtract the top. What's the derivative of tangent? Times the derivative of the bottom, that's secant squared, and then, or you can write tangent squared x. All right, f of x and g of x are inverses. So when I think inverses in calculus, that means reciprocal. So that says there's a point. So at the point pi/4 and root 2, the inverse of that would be root 2 and pi/4. So notice that's what we're looking for. So first of all, I need to take the derivative of f of x. That's -2 sine x. Then I'm going to plug in pi/4 into the derivative. So if I plug in pi/4, the value of sine at pi/4 is root 2/2. The 2's cross out, and it says negative root 2. So that means the answer I'm looking for is the reciprocal of that. I don't need to be fancy with it. I can just go -1 over root 2. Or negative root 2/2. All right, how about implicit? Try it first. So the derivative of 2y is 2 with a hook, y prime. The derivative of e to the y is e to the y with the hook y prime. The derivative of x squared and 3. Factor out a y prime from 2. And e to the y, add 2 to the x to the other side, and then divide, and you have your answer. I'm impressed that so many of you are doing very well with implicit, and that's really impressive. Where are we at? Let's see if you did this one right. Big fraction, square root 1 minus 2x squared, and the derivative of 2x is 2. The derivative of secant is, the hook is 4, and it's secant tangent. Logarithm, right? I know you can copy me. You're not copying, right? So a fraction. This 2 is part of the answer. What I see goes in the denominator. The derivative of that would be in the numerator. But because it's not ln, it needs a ln 3 right here. Or is it in the numerator? Which one is it? Denominator or numerator? Think about it. Yeah, it's in the denominator. I'm going with it. Here we go. I don't even know. I'll be back. Make sure I double check my rules. You can fast forward. Yes, it's in the. I knew. Why was I doubting myself? I knew. It's in the denominator. All good. All right, derivative. I hope you did this one first. So 1 plus, now the square root of x squared is just x, and then the derivative of that is the numerator of the hook. ln is a fraction. What you see is in the denominator. The derivative of cotangent is negative cosecant squared. The derivative, copy, then the hook. So the derivative of tangent is secant squared, and then the derivative of 4x is 4. So make sure you follow. Oh, and it needs a hook, ln 3, because it's not e. So we have our hooks, and it needs a friend at the end because the base is 3 and not e. All right, how about integrating? You need to do this whole page first, then see if you did it right and learn from it. So the hook is 2, so I need 1/2. So it starts with 1/2. Sine is negative cosine plus c. We're going to write this friendly. That's 1 minus x squared to the negative 1/2. The derivative is negative 2x. It was positive, so I just need a negative in front. So this negative 2x is not part of the answer, so it's just negative, and then add 1 to the exponent. That's what I meant to say. So negative 1/2 plus 1, that's positive, and then divide by that. You could also do the reciprocal and say it's negative 2 in front. How about this one? This one's arctangent. So the square root of 4, the square root of x squared, and the derivative of x. So this should be a 1, so it was a 2. So the answer starts with 2, and then 1 over a, and then arctan u over a plus c. This is a logarithm. The derivative of tangent is secant, so it's done. This one is arcsine. So a is the square root of 16. U is the square root of x to the 4th. U prime is 2x. So this should be a 2x. So it was a 4, it became a 2. So our answer starts with 2. Oops. Try it again. So our answer starts with 2. Arcsine does not start with 1 over a. That's only arctangent. So it's just arcsine u over a plus c. Oh, what are we going to do here? The degrees are the same. So what do I do? I think you know more than you let on sometimes, you know? Like we've done a lot of work this year, and then we're going to practice to make sure it comes through. So x squared divided by x squared is 1. So we have x squared plus 1. I'll put that over here. And then I'm going to subtract. So I get 3x, take away 0. So this is 3x. So I have 1. And then I have 3x over x squared plus 1. So the question is the fraction there, what is that? And the answer is it's a logarithm. So the derivative of the bottom is, so first of all, the antiderivative of 1 is just x. The hook here should be 2x. It was a 3. It became a 2. And that's it, plus c. And it's a logarithm. So the derivative of the bottom matches the top, and I just need 3 over 2 as an adjustment to what the hook is. We need to complete the square. So 2 divided by 2 squared. So we're going to add 1 and subtract 1. So again, we're going to add 1 and subtract 1. So when I go x squared plus 2x plus 1 and I factor it, that's just x plus 1 squared. And then negative 1 plus 5 is 4. And there you can see arctangent. So the square root of 4, the square root of x plus 1 squared, and the derivative. So it was a 3, became a 1, so our answer is going to start with 3, then 1 over a, then arctangent, and then u over a, and then plus c. Keep trying it first. The hook. So the hook is negative 2. It was a 1 in front, and it became negative 2. So our answer is going to start with negative a half. And the rule for E, so this goes away. The rule for E is copy. And that's it. Plus C. The hook here is 3, so we need a 1/3. The rule to integrate tangent is not secant squared, right? It's negative ln cosine. And then plus C. Different, right? To take the derivative than to integrate. Write this friendly. The hook is the derivative of cosine, which is negative signs. We need a negative in front. And then I add 1 to the exponent and divide by that exponent, and it's over. Here, the hook of ln x is 1 over x, which is there. So the 1 over x, the hook, is not part of it. To integrate secant squared is just tangent. So it's just tangent ln x plus c. The hook is negative 3, so I need negative 1/3. And then the rule for cosecant. Do I have a rule for cosecant? I might have done that wrong. We don't have a rule for cosecant. So let's pretend I changed this question to cosecant cotangent so that we can do something, and I'll change it for like later purposes. But right now, I just made a typo. It should say cosecant cotangent. It's still a hook of negative 1/3. And then what's the rule for cosecant cotangent? It is negative cosecant. And the negative will actually make it plus now, because the two negatives. There, we fixed it. All right, those are the rules. Now can you apply some of the rules? Find the equation of a tangent line. So what is x equal, y equal, what's the slope? So x is 0. The y value, if you plug in 0 for x, I get 0 plus 1. That's 1. E to the 0 is 1. So 1 times 1, so there's the y value. To find the slope, I need to take the derivative. This is the product rule. The first times the derivative of the second plus the second times the derivative of the first. And then again, I'm going to plug in 0. So if I plug in 0 again, I get 1 times 1. Plug in 0, I get 1. So this is 1 plus 1. It's 2. So the slope is 2, and it's x minus 0 plus 1, or you can just write down y equals 2x plus 1. Both are correct. All right. Increasing and decreasing. What type of question is that? And the answer is it's a derivative question. So I'm going to take the derivative here by doing the quotient rule. That's the bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. Now, I need to know the critical numbers. And so we're going to have a critical number at -1 because it's undefined. I'll write that down. Critical numbers. -1 makes it undefined. If I look at the numerator and I distribute, I get 2x squared plus 2x minus x squared. I'm going to make that equal to 0 and solve it, and then that will give me my other critical numbers. So 2x squared take away x squared is 1x squared. Factor out an x, and my other critical numbers are 0 and -2. So those are my critical numbers. I then draw a number line for those critical numbers. And then I plug into the derivative. So if I rearrange the derivative again, so the derivative factored out would look like this. It's just easier when it's factored in terms of this to understand. So if I plug in -3, what would happen? So a negative times a negative is positive. This is always positive. That means it's increasing. Negative 1.5. A negative times a positive is negative over a positive. Negative 1/2. That's a positive times a negative again. Let's try negative 1.5. Say again. So negative 1.5 is a positive, negative, negative. Negative 1/2 is a positive and a negative. So that is also negative. Remember, this is an asymptote. That's what I'm forgetting. But no, this is an asymptote. And then plug in 1, 2, 3, 4, 5. Doesn't matter. It's positive. So that tells me where it's increasing and decreasing. So where is it increasing? So from negative infinity to negative 2. So again, just so you know, are you okay finding the critical numbers? Are you okay plugging in a number into the derivative to see if it's positive or negative? And if you can't do it mentally, write it down so you understand if it gives you a positive answer or a negative answer. So we're increasing. Here we're also increasing from 0 to infinity. And then where is it decreasing? And you can say negative 2 all the way to 0 if you want. Or you can split it up into 2 intervals. Both are correct. Okay, at what point is the relative maximum? So notice this is point, x and y coordinate. So the maximum is right here, where it goes positive to, so it increases and then decreases. So the maximum, the relative max, is when the x coordinate is negative 2. How do I find the y coordinate for the point? And I plug it back into the function. So negative 2 squared is 4. Negative 2 plus 1 is negative 1. So it's just 4 divided by negative 1. So there's my maximum. For my minimum, it goes the other way, which means it decreases and then it increases, and that's at 0. So if I plug in 0, 0 divided by 1, the answer is 0. So at negative 2, negative 4, we have a maximum, and at 0, 0, we have a minimum. I'm going to just do a fun sketch in a moment. And it says, what is the maximum and minimum value from negative 5 to 1? That's a table of values question. So we have negative 5 and 1. What are the critical numbers between negative 5 and 1? Well, all of them. Negative 2 and 0 are part of that. And then we already know at negative 2 the answer is negative 4, and at 0 the answer is 0. Do these give me answers that are less or more than that? So negative 5 might take a little longer, but it's 25 over negative 4. So 25 over negative 4 is smaller than negative 4. So if I went 25 divided by negative 4, that number is a bigger negative number than negative 4. When I plug in 1, I get 1/2. So now I have a sense of the smallest number and the biggest number. So the absolute max would be 1/2, and the absolute minimum in that would be negative 25 over 4. So that's my largest y value and my smallest y value. If I wanted to graph this, at negative 1 would be an asymptote. At negative 2 and negative 4 would be a minimum. And at, where's the maximum? Oh, at 0, 0 would be the maximum. So we know here you'll either go to infinity or negative infinity. So we know that after negative 2, it decreases. So it's going this way. We also know this decreases too. So we have a sense of what's happening. And I just want to know the end behavior. If I look at this, it's x squared over x. And if you look at the power terms, the oblique, it actually, if you divide it, the right end goes up and the left end goes down. But we have our turning points and our asymptote. There is no horizontal asymptote here. It's slanted, so it'd be like this. And that was what your graph would look like. All right, just for fun, right? How about concavity? How do I do that? Concavity is a second derivative question. So the first derivative And now the second derivative. And can I just mention this? That let's say you have forgotten about increasing and decreasing, or have forgotten about concavity. You can even do the new book that we got, the test prep book. Look in the back index and look under these topics, and you can practice with that book if you need to practice. All right, the critical number, make it equal to 0 and solve it. If I solve the second derivative, the critical number is 2. So I'm going to draw a number line for 2 for the second derivative. And into it, if I plug in like 0, it's negative. If I plug in a number bigger than 2, it's positive. So where is it concave up from 2 to infinity? Where is it concave down from negative infinity up to 2? And the point of inflection is here because the concavity changes. So the point of inflection would be at 2, and then you would plug in to get the y value. So what would that be? 2 cubed times 2, 2 squared, 4, that's 48. Let's see if I can do this. 20, take away 48, I think, is negative 28. I'm going with it. All right, at what C value, the mean value theorem? So the mean value theorem is when A rock equals I rock. So I do need to take the derivative of this, which is 2x minus 1. And I need to go y2 minus y1 and x2 minus x. So these are my x's. That's my denominator. Plug in 4. That's 4 squared, 16. Take away 4. And plug in 0. That's 0. And then I solve that. So when I solve it, the A rock is 3, and that's the I rock. And then we make them equal to each other, and then you solve it. So the C value would equal 2. When you solve it. And notice it's in there. And so the mean value theorem, that at least at one point the instantaneous and the average rate change would have the same value, at least at one value, as long as this is continuous and differentiable from 0 to 4. Okay. Some position, velocity, acceleration question. So this is the position of an object. How would you find the velocity? So the answer is you take the derivative. So that's x squared over 2x. That's how you take the derivative. And then at 1 second, you'd plug in 1, and you would get the answer 1, and it would be feet per second. What's the acceleration? Now we have to use the quotient rule. So that's the bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. Might take a little more thinking to do this. Plug in 2. That's 5 times 2. That's 10. Times 2 times 2. That's 4 times, so it's 16. So 10 take away 16. 2, 5, 25, right? And that's feet per second squared for acceleration. If I'm wrong, let me know in class. I think that's okay. Hey, what's the initial speed? Well, the initial speed is the absolute value at 0. So at 0, if I plug in, the answer is 0. So initially the object is at rest. But if this was a negative answer, it would change to be a positive answer for speed. But initial means you plug in 0 for t. And if you plug in 0, you get 0 divided by 1, which is 0. All right, when's the object at rest? So the only critical number for the velocity is at 0. Nothing makes it undefined. So you would draw, for velocity, you draw a number line at 0. If I plug in a negative, it's negative. If I plug in a positive answer, it's positive. So it's only at rest when t equals 0. When is it moving right? From 0 to infinity. So when the velocity is positive, it's moving to the right or up. And where is it moving left? Is from negative infinity to 0, the negative velocity. All right, how do I find average value? That's an integration question. So I'm going to integrate this and then divide by the difference of the bounds. So how do I integrate this? This is arctangent. So A is 1, U is 2x, and then the derivative of U is 2, which is all perfect. I don't need any. But instead of dividing by pi over 8, I can just do the reciprocal. And this one's going to be arctan. Starts with 1 over A. but a is 1, so 1 over 1, I don't need the 1 in front. Arctangent u over a, which is 2x over 1, or just 2x. And then I'm going from 0 to pi over 8. Okay. So we have 8 over pi. First I'm going to plug in pi over 8. Now, plug in pi over 8 2 times. What's 2 times pi over 8? The 2 and the 8 cross out and give you pi over 4. So this is arctangent pi over 4 minus arctangent 0. And that's it. Now, you think that the value of tangent at pi over 4 is 1, but arctangent pi over 4 is not that. This is a calculator question from here, but we can leave it just like that. All right, find the area bounded. That's a integration question again. Area. So I want to find, I'm going to do a little graph here from 1 to 3. So if I plug in 1 plus 3 is 4 divided by, that's 4. So at 1, 4. And then if I plug in 3, I get 9 plus 9, 18 divided by 9, I get 2. There it is. So I have, and I know there's an asymptote at 0, so it's like it's decreasing here because it kind of looks like this with an asymptote at 1, believe it or not. But it doesn't matter right there. So that's what we're looking at. And so we want to find n at y equals 0. So x equals 1, x equals 3, y equals 0. This is the area I'm looking for. And then how do I find area? So I integrate from 1 to 3. I'm going to integrate x squared plus 3x. So you integrate, subtract 0, which we don't need to do. So this will find the area under the curve. How do I do that? The quickest way is not long division here. So instead, x squared divided by x squared is 1. And then if I cross out x and x squared, I get 3 over x, which is the same as 3x to the negative 1. And that's much easier to then integrate and then plug in. So the integration of 1 is x. Here, I'm going to add 1 to the exponent and divide. Oh, I can't do that. So let's not do that. So instead of looking at it like this, because as soon as I added 1, it's 0, right? So I'm like, wait a second, it's a logarithm. So we get 1 over this. So there we go. So now, when integration of 1 is still x. But 3 over x is a logarithm. So the derivative of x is 1, but we need 3 in front, so it's 3 ln x is the integration of 3 over x. And then not plus c, but from 1 to 3. And then plug in 3 first, and you get 3 plus 3 ln 3. That's also ln 27. Subtract 1, and then ln 1 is 0, but you can write that in if you want. And then that's the area of it. So if you actually simplified it, you would actually get 3 subtract 1, which is 2, and then you could even write ln 27. That would be like a kind of a multiple choice question to see, do you know your logarithm properties? So this 3 is actually an exponent inside, and 3 to exponent 3. And then combine like terms, ln 1 is 0. So could you match it up and so on. Find the volume by revolving the area bounded by that and the line y equals 2. So first of all, what does this graph look like? So e to the x, I know what it looks like. And then e to the negative x is reflected. So it kind of looks like this. So instead of increasing, it decreases. So that's e to the negative x. So e to the positive x, and then it reflects over the y-axis. So now it's decreasing. And then if we take the x and the y-axes, the x, the y, I might have missed one, y equals negative 2. So we want to revolve this. So I need to add one more information. So one thing I need to add is we have the x-axis, but I need another x value. So I'm going to do it right here. I'm just going to give it x equals 2 so that we have this area here that we're going to revolve. So I'll add that for later on. Now there's two things I have to go through to add. So x equals 2. So we have the y-axis and x equals 2 and the x. So now it's all bounded, 4 sides. And then I'm going to revolve this. So revolving is, first of all, going to be a circle. So it's going to be pi r squared. And there are 2 circles, right? So there's a space there in between. So there's going to be 2 radii. So the big radius, the top, subtract the bottom, will be e to the negative x is the top, subtract negative 2 or add 2. And then the second one is 0, subtract negative 2 or just 2. And there's your setup. Now, I know it says to find the volume, but really I just want you to set it up because you would then FOIL this. You have 4, which you can, pi in front. It's going to take a while. So could you set this up to find the volume to rotate? And that's the correct setup. All right, use a tangent line. So when x equals pi, so the y coordinate, if you plug in pi, you get cosine at pi, which is negative 1. So first of all, what's the value at pi? So 2 cosine pi plus pi. So what did I get? That gives me negative 2 plus pi. And then the slope. What's the derivative of this? So the derivative here is negative sign. And again, if I plug in pi here, the value there is 0, so the slope is just 1. So the equation of the tangent line is 1, which I don't need, x minus pi, and then the y coordinate. So if I combine like terms here, I would get x. So remember, we're multiplying here. So this is x. I have minus 2. And then negative pi plus pi, they cross out. So this is x minus 2. And then to use that line to approximate, I would plug 2.1 into that line and get the answer 0.1. That question worked out, which is nice. All right. Hey, slope field. So use the grid above to draw a slope field for these points using this. So I know that what happens when y is 0, 0 times anything, that means all the slopes here are 0. I also know that when x equals 2, so 2 take away 2 is 0. So here's 2. These are also horizontal. And then I need to fill in the rest. So whatever, left to right. What's the slope at negative 1, negative 1? So that's negative 3 and negative 1, which is positive 3. So I draw a slope at positive 3. What's the slope at negative 1? Oh, shoot. It's negative 1, positive 1. So let's try it again. So negative 1, positive 1. So that's negative 3. That's going to be a negative 3 instead of a positive 3. So this should be down like this. I can correct it. So negative 1 and 2. That is negative 3 times, that's going to be negative 6. So super vertical almost. The next one is at 0 and 1. So plug in 0, that's negative 2 times 1. The slope at 0 and 2, that's negative 4. The slope at 1, 1, that's negative 1 times 1, that's negative 1. The slope at 1, 2, that's negative 1 times 2. And then I got room for one more here. This is 1, 2, 3, and 1. So at 3, 1, it would be 1 times 1, which is 1. And then the last one, which is at 3 and 2. So 3 take away 2 against 1 times 2, that's going to be 2. And then draw the slope field through 1, 1. So here's 1, 1. So it's going up to the left. It comes down. And then here, right where the horizontal lines are, it's going to turn. And then it goes up on the other side. So there's your solution through 1, 1. Then it says solve the Diffie Q through 1, 1. So let's solve this Diffie Q. Oh, you know what this should say? This should say here. So there's another little typo. That should say f prime at x equals that. So in other words, dy by dx is equal to that. So let me change that. It's okay. So as I go through this, and if I make a mistake on the video, there it is. And then I'll type it out differently next time. All right, separate the variables. So we're going to divide by y, and I'm going to multiply by dx. So we separated them. Integrate this. This is a logarithm. This is x squared over 2 minus 2x plus c. You can plug in the point 1, 1. So 1 for y and 1 for x. Ln 1 is just 0. This is 1/2. So 1/2 take away that is negative 3 over 2 or negative 1.5. Add it to the other side. And then you have ln y equals x squared over 2 minus 2x plus 3 over 2. To know what y equals, it is e to all of this. Another way we could have done it, instead of plugging it in right there, we could have written it as e to the exponent x squared over 2 minus 2x times e to the c. And then we could have replaced it with an easier constant. Would be algebraically the same, what we're doing. And then if you plug in 1, 1, you would get a different answer, and then you could do it. But it's the same, they're algebraically equivalent. But you can plug in 1 for y, and then 1 for x, and then get c2 by itself by dividing. It's going to look a little awkward. I think this is an easier solution, to plug in 1 and then write it as an exponential. The base is e, the exponent, and then y, and then you have your answer. All right. Last page. Easy peasy. It's not even going to be an hour. All right. The above graph shows the velocity in miles per hour of a Vespa. I love Vespas. That's a moped. Fancy in Italy. Luca. Over a 4-hour period. There's another. That's how you know when you make mistakes, right? But it's okay. 4-hour period starting at 1 p.m. Okay. So know that this is 1 p.m., 2 p.m., 3 p.m., 4 p.m. So it's a little, gotta be careful of the numbers. So what is the velocity at 2:45 p.m.? So if this starts at, I'm even going to change the graph so like you can understand it. 2 p.m. So I'll write over it, right? So you understand what's happening here. So at 2:45 p.m. it's right here. And the velocity there at 2:45 is 30 miles per hour. Done. What is the velocity of the Vespa at 1:15? So here we are at 1:15. The velocity here is a point at 1:15, somewhere here. So I can't just guess it. I actually need to know the equation of this line, which is easy. So the equation of that line, the slope, rise over run, is 30. This is a 1 really, just 2 p.m. So 30 over 1, that's 30. And the y-intercept is at 0. So it's just 30t, which means if I plug in 1:15, now think of 1:15 as a quarter past, right? 0.25. Then you would plug in 0.25 and you would get your answer. So it's 7.5 miles per hour. So we needed an equation of just slope and the intercept 0, and then plug in and understand what 115 is as a decimal. So that's 1/4 after the hour, right? Quarter. And then plug in the quarter. All right, what's the acceleration at 4:30? So at 4:30 here, acceleration is the derivative of velocity. In other words, what's the slope here? So we went down 10 and to the right 1. So the acceleration means we're decelerating, right? It's -10. That's the slope of there. All right, integrate from 0 to 4. So again, this is 0 and this is 4, meaning I got to integrate everything. So let's be easy on our brains. So I got a triangle. That's 1/2 the base and then the height plus the rectangle. So 2 times 30. And then I'm going to use a trapezoid here. So 1/2. The height is, it's actually on its side, so the height of it is 1. And then the two bases, which are really like it's been flipped on its side, are 30 plus 20. So 30 plus 20 is 50. So if I put this together, I got 15, 60, and 25. If I add that up, it's 100, isn't it? And then write a sentence explaining the meaning of the answer above. So from 1 p.m. to 5 p.m., because that's what it means, 4 hours starting at 1 p.m. So 1 p.m. to 5 p.m. The Vespa traveled a total distance of 100 miles. All right. How about these questions? What happens to the derivative in integration? They cross out. This is called the fundamental theorem of calculus. So this is just a substitution question. So what happens when I plug in -1 and then I take the derivative of that answer? The answer is 0. Here, if I plug in and take the integrate and then take the derivative, it kind of just go forward and then backwards again. I just plug in 2x for t, and that's it. Oh, and the hook. And the derivative of 2x is 2. So your hook comes from the limits or bounds. So let's try it again. So first of all, pi and e are just numbers. So if I plug in pi and integrate and derivative, that's 0. E is just a number, same thing. If I plug in e and integrate and take the derivative of any number, this answer is just 0. I was just trying to be fancy. Then here we have algebra again. So we take the top and we plug in. So instead of here, this should be t. Typo again too. All right, this should be t. So plug it in for t. So that's tangent x plus 1, and then the derivative of tangent x is secant squared. Subtract top, subtract the bottom, and then 3 and cosine x plus 1, and then the derivative of cosine is negative sine, and you did it. All right, so if there's something you need to practice, you can do the question over again. You could look in your big book. You could look at your prep book. We can talk about it. But first of all, I'm proud of you for reviewing with me and finishing the packet and having a great attitude. And you're not perfect, and I'm not perfect. And we're going to try our best on the final and try our best to prep and pass and so on. And that's going to be good enough for me, that you're doing your best to keep working at calculus. All right, till next time, I'm proud of you. Mr. GMath.